Hello friends, welcome back to my YouTube channel. So in previous video we have seen the degree of static indeterminacy for beams and as well as trusses and planes. We have solved also some problems on that. So we have completed the static indeterminacy part. So now we are moving degree of kinematic indeterminacy, and before that we'll see the what is degree of kinematic indeterminacy. So degree of kinematic indeterminacy, it is also called as degree of freedom. It is denoted as d, dk. K is kinematic and d is degree of indeterminacy. So what's mean by degree of freedom? So it means it is a total unknown joint displacement of a structure. It is called degree of freedom. So now in this video we will see the degree of freedom for beams. So in degree of kinematics there are two types. We can solve the problems for beams with considering the axial deformation and without considering the axial deformation. So in this video we will solve the problems with considering the axial deformation. So for that we have the formula dk is equal to 3j minus r plus e into c, where j is as usual number of joints and r is the number of reactions and ec is the number of internal hinge. For that we have the formula m dash minus 1, where m is the member connected to a hinge. So before starting this we'll see degree of freedom means what. So with an example we'll see. Have taken one structure. So in beam at any joint, if you take this at any joint, the degree of freedom, so I will show here. So if you take any joint in a beam, how much it can deform at a joint, the possible deformation way is, I will show here the. So one is axial deformation. If you take any joint in a beam, the possible deformation at a joint will be, one is axial deformation, it is also called as a horizontal deformation, and one is moment and another is vertical deformation. The possible deformation at a joint is three. One is horizontal or axial and another is vertical, and one moment will be takes place at any joint. But how many reactions are there in a roller support? One. So how many reactions are there at a roller support? One. That is vertical reaction. So here look at here what happens here. I will show you in easy way. I am redrawing this structure here. So this is the beam at any joint. This is a fixed, and hinge is here, roller is here. At roller suppose vertical reaction is there. So at any chance how many deformation, the possible deformation is, one is moment and horizontal and vertical at any joint. At roller suppose the possible reaction is only vertical reaction which takes place. Here what happens here, at these joints the vertical deformation, it is trying to deform vertically, but the reaction is there in opposite, so that both are get cancelled with each other. So at roller support the how many deformation will remain, one is horizontal and moment. The degree of freedom is 2 at roller support, because there is no horizontal reaction in opposite side and there is no rotation, it can rotate freely. So only the vertical deformation and vertical reaction will get cancel each other, because because the vertically this can resist, so get cancelled with each other. So at if you come to this support, the possible deformations, one is horizontal and vertical, and 3 the deformation is at this term 3. So in our roller fixed support, the how many reactions, one is horizontal and vertical and one is movement is there. So here what happens, here also rotation is there, here also rotation, both are will get cancelled, and the vertical reaction is there and vertical deformation is there, both will get cancel each other. Here on the horizontal deformation is there, here horizontal force is there, both are get cancel each other. How the degree of freedom will be here 0. At fixed support the degree of freedom will be 0. This is how we calculate the degree of freedom considering axial deformation. I will show. Here what happens, remember at any joint in a beam there will be the possible deformation will be 3. One is axial deformation, the axial, don't get confused here, the axial deformation is also called as the horizontal deformation, both are same. So one is movement and one is vertical deformation. So we'll see at in support, this is the in support. At in support, the how many reactions are there? 2. One is vertical and horizontal. So what I told, at any joint the possible deformation is 3. One is horizontal, vertical and movement is there. So here horizontal reaction is there and horizontal deformation is there, both will get cancelled with each other. Here one vertical force is there and vertical deformation is there, both will get cancelled with each other. So at in support there is no rotation, so in deformation there is a rotation, it can rotate freely. So the rotation is there, in inch there is no rotation, it can freely rotate, the inch cannot resist the rotation. So here degree of deformation is at in support, the decay is 1, because in deformation there is the rotation, in at our in support there is no rotation. This is how we calculate the axial deformation. So we'll see at roller we have seen an inch, and fixed also we have seen. There is one more, that is internal hinge. So if you take at any internal hinge, there will be the possible deformation will be 4. The rotation is takes here also rotation comes in both direction, one horizontal deformation and vertical deformation. So decay at in support is, it will be 4. At inch the our reaction is 3, vertical, horizontal and one moment is there. At this joint also the deformation is horizontal, vertical and moment, the both will get cancelled with each other. Here moment is there, rotation is there, here also rotation, both get cancelled with each other. And here vertical force is there, here vertical deformation is there, both will get cancelled with each other. At fixed support decay is 0. So at roller we have seen here, this is how we calculate the our degree of freedom. So we'll see some problems. You can calculate manually or also you can calculate by using this formula. I will show how to calculate manually as well as by using this formula. I hope you understood this. We'll solve some more problems on this. See here I have taken one structure. Here this is the roller and one internal hinge is there and fixed support. First we'll solve by using the formula. The formula is what? The formula is 3j minus r plus e. 3j minus r plus e. dk is equal to. So how many joints are there? 1, 2, 3. 3. How many reactions are there? Hinge 1, support, a fixed support 3. Total 4. How many internal hinge is 2 members? We have the formula m dash minus 1. M dash is 2. 2 minus 1 is 1. 2 minus 1 is 1. So now substitute this formula. So right here 3 into j is joint 3 minus r is 4 plus ec is 1. 3 into 3 9 minus 4 plus 1 3. The answer will be 6. So dk is 6. We'll move to the structure. How many joints are there? 1, 2, 3, 4. Number of joints 4. The how many reactions are there? Here 3, here 2, here again 3. The unknowns are 8. 3 plus 3 6, 6 plus 2 8. Internal, there is one internal in EC is equal to m dash minus 1. Member is 2. 2 minus 1. Again 1. Here this is 1 not 2. EC is 1. Will get 1. So substitute in our formula. Our formula is 3 into j is 4 minus r is 8 plus EC is 1. 3 into 4 12 minus 7. The answer will be 5. So dk will be 5. Here how many joints? 1, 2, 3, 4. Again 4. How many reactions? Here 3, here 2, 2. How many total reactions? 3, 5, 7. Total reaction is 7. And our EC is internal hinge is 2 minus 1. M dash is 2 members are connected. 2 minus 1. So 1. So dk is 3 into joints are 4 minus reaction is 7 plus EC is 1. 12 minus 6. The answer is 6. So dk is 6 here. So we'll see one more problem. How many joints? 1, 2, 3, 4. How many reactions at fixed? 3 hinge 2 roller 1 and fixed again it as 3. So 3 plus 3 6 7 8 9. Total unknowns are 9. There is no internal hinge, so our EC value is 0. Now substitute in our value. So dk is equal to 3 into joints 4 minus unknowns are 9. 3 into 4 12. 12 minus 9. Our answer will be 3. So dk is 3. Here how many joints? 1, 2, 3. Joints are 3. How many reactions? Here 2, here 3. Unknowns are 5. There is no internal link, so EC value is 0. Now substitute in our formula. dk is equal to 3 into 3 minus 5. 3 into 3 9 minus 5 is 4. So our dk is 4. We'll see one more problem. Here the number of joints are 1, 2, 3, 4, 5. Joints 5. So how many reactions? Roller edge 1, fixed 3, here 3. 3 plus 3 6, 6 plus 1 7. One internal hinge is there. EC is equal to m dash minus 1. How many members are connected? 2. Here 2. 2 minus 1 1. So now substitute in our formula. dk is 3 into 5 minus 7 plus 1. 3 into 5 15 minus 7 plus 1 6. The answer will be 9. 15 minus 6, it come out as 9. So this is how we calculate by using formula. So now we will see how to calculate without using the formula by only considering these values. By seeing this also we can calculate directly without this formula. If you don't remember this formula, we can calculate manually also. So I will show you how to calculate manually without the help of this formula. So at in support, how many here? The value of decay at in support is 2. So because I will show one more time. At in support the reaction is 1 vertical. Wait. The reaction is vertical only 1, but in our joint, if you take any joint, how many deformation? The possible deformation is vertical, horizontal, movement and vertical. So here the vertical force will get cancelled with each other. Here also vertical is there, and one vertical deformation and vertical reaction is both will get cancelled. The remaining 2 deformation will be there. The degree of freedom is 2, only to add the roller support. So our dk is here 2. Our dk value is here. At any internal hinge our dk is 4. One is rotation will take in both the direction, clockwise and anti-clockwise, and one horizontal deformation is there and vertical deformation is. Total number of dk at internal hinge is 4, and at fixed is 0. As I told, there is no degree of freedom because the fixed has the 3 forces, horizontal, vertical and one movement. So at fixed joint the degree of freedom will be like this: one movement on horizontal, on vertical. So your vertical get cancelled and horizontal get cancelled, and rotation will get cancelled. The value of dk as joint is 0. So total how many number of dk? 2 plus 4. Here is 0. 2 plus 4 is 6. So dk value is 6. So our answer will be same. For dk is manually it also comes 6. 2 plus 4. If you see here at joint, as I saw, our dk value is 0 here, and at hinge is, I will show one more time. The hinge is there is horizontal and vertical reaction will take place at this joint. The possible deformation is vertical, horizontal, one moment. The horizontal will get cancelled, and your vertical force will get cancelled. The only what is remaining, the rotation is remaining. It can freely rotate. It cannot resist the rotation. So dk value at hinge is 1. So our internal hinge, the deformation is 4, as I explained. Fixed is 0. So 1 plus 4, 5. So dk is 5. The both answer is same. Here at fixed our dk is 0. At hinge there is 4, as I told. At hinge, here at hinge our dk value is degree of freedom is 1. So here also in support is there, here also 1. The total number of freedoms are 4 plus 1, 5, 5 plus 1, 6. So dk is 6. Both answers same. At fixed degree of freedom is 0, at hinge 1, at roller 2, at fixed 0. So 1 plus 2, dk is 3. Here at hinge degree of freedom is 1, and at support degree of freedom is 0. So here one joint is there. So remember, whenever the joint is there, the possible deformation at a joint is how much? 1 is rotation will take place, 1 is horizontal and vertical. So total possible deformation is 3. 1 plus 3, 4. 4. So decay is 4. So at roller, decay is 2. At internal hinge, it is 4. At joint, again 3. As I told you, one horizontal, one vertical, and movement is there at joint 3. So at hinge 4. Rotation horizontal and vertical, 2 rotation and horizontal and vertical. So here also 0, here also 0. So 2 plus 4, 6, 6 plus 3, 9. So our answer is 9. So this is how we calculate the degree of freedom manually without the help of formula. The answer will be same. So if you don't remember this formula in exam, you can calculate the by simply remembering the value of dk at hinge support, as hinge at internal hinge, at fixed at roller support. You can calculate easily. So this is how we calculate the decay with consideration of axial deformation. This is how we calculate the decay manually without using the formula, by simply remembering the value of decay and with consideration of the axial deformation. I hope you all are understood. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.